This
FPGA
conference will now
technology.
be recorded.
Yeah, Monisha, Priyanka, can you please tell me like what is your familiarity with the FPGA technology? Hello. I'm audible.
Yes, sir, you are audible.
Okay. What do you know about FPGA? Have you heard of FPGA? And if you have heard, so what do you know about FPGA?
So basically, it is a field means a particularly used for prototyping applications
Mm-hmm.
and to design a processor and for any bugs-free manufacturing like ASIC flow. Then we are using this FPGA.
Okay, so that is one of the application. Okay, so like whatever you said, so that is one of the application prototyping, but it need not be prototyping always. So nowadays you might have heard about 5G accelerations, right? Artificial intelligence acceleration, 5G technology, especially in case of 5G technology. Maybe like every 10 years now, if you look into the like past few years, so like every 5 or 10 years, your like the generation is getting changed. Like previously it was LTE, now people are talking about 6G, and now people are also talking about artificial intelligence. What happens actually, like when the technology is rapidly changing, so people cannot afford going for different ASIC for each technology. So now what people are doing, they are building the hardware, all the whatever the existing hardware, so using FPGA. So that's why nowadays, like if you just go to the LinkedIn or like Naukri and search FPGA, you can find like thousands of job profile with respect to LinkedIn to that. So many people will think whenever like the term FPGA comes, it can be like only for prototyping or verification purpose. So, but it is not that way. So nowadays it started getting like more popular in the system design as well. Like so, we are developing product based out of like FPGA. So I basically work for 5G technology, where like from past 4 5 years, like we are working for 5G based products for various vendors or customers. That is actually like application front of FPGA part. And nowadays, like you might have seen, like there are like a lot of ASIC or Verilog or PD engineers are coming, right? So, but this FPGA is a field. It's like slightly unique, where you find very difficult to find the engineers. And nowadays, like people are paying very much higher end to these FPGA engineers for, because like it's now for artificial intelligence and 5G, right? So especially this prototyping has to happen within few years. But they're finding the scarcity for FPGA engineers, because many people are like mostly focused on ASIC or Verilog domain, where like FPGA domain is still lacking in the resource wise, right? So that's why like this FPGA is like very what to say, very popular, as well as like you can have a bright future in this field. And one more good thing about FPGA is like once you are getting familiar with the FPGA, right? Since like in FPGA you'll get to know entire flow, and you will have, I mean, you will have hands-on on all the part of what you might have gone through in the ASIC field. Like in ASIC, if you see ASIC profiles, you will be having something like FCA engineers, or only timing closure engineers, or only physical designers, or synthesis engineers, so a front-end engineer. So different fields will be there. Whereas in FPGA, you will get to work in all the domains. So it will be like expertised in all the domains when you work for the FPGA, because you have to go through all this stage if you want to test it on board, right? If you are a FPGA engineer, there is always chance to jump into ASIC, or like if you find that ASIC is a particular part of ASIC is interesting. Like for instance, in FPGA you like to do timing closure, or if you do like to do RTL coding. So any one of the part which if you like, So then that you can put it into ASIC, because like ASIC and FPGA, like in the front end wise, it does not differ much. So it is like conceptual wise, it is almost same. Okay. So that's why like FPGA career is like nowadays, like I say, it's like it's getting more popular and popular, and like since many people are into the ASIC, and like we are finding difficult to find FPGA engineers, and like that's why the demand for the FPGA engineers are growing every day. Coming to the our like course structure, what we had planned for, especially for like facing FPGA engineers. So like I came to know that you guys are gone through like various back end courses, or it may be like system verilog courses, right? So having that background, so how to prepare for FPGA? So since already you have a digital background, it's very easy to understand the concepts behind like FPGAs. Like if we have some short term kind of crash course, so you can easily get into the concepts of FPGA basically. So that's why we planned a short term course, maybe like it may last for maybe 18 to 20 hours. So where I'll try to cover overview of FPGA technology, where you can face any interviews. I mean, being like how as an experience, how you can face a interview, right? So I'll try to teach in that way, so that you will get some knowledge in at least to that level, at least maybe like the entry level guys, like maybe 2 to 3 years of guys. Okay. So let me straight away jump into overview of course. So I'll just touch upon like whatever I'm going to cover in like upcoming sessions. So initially, it will be introduction to FPGA design, in the sense like we will be going through various FPGA vendors architecture. So internally, we need to understand before building any RTL, or before writing any front end code, we should understand what is there inside FPGA, right? So we will be like, and most of the interview questions will be like on the very fundamental end. So in the sense like they will try to understand whether you have really understood what is there inside FPGA, maybe like resource wise, or routing resource wise, or how to program. So such questions usually it will be popping up frequently. So we will try to understand very fundamental aspect of FPGA, that is like internal architecture of FPGA. Okay, like so how it is being evolved, and like what are the architecture with respect to. We'll try to understand with respect to Altera as well as Xilinx FPGA. So as Altera and Xilinx are the two vendors, maybe like very most popular vendors. There are like various other vendors as well, like Microsoft. These guys are also providing FPGA, but most popularly used two FPGAs are Altera and Xilinx based FPGA. So we will study architecture of both. Maybe like mostly we'll be focusing on Xilinx based architecture, but I'll give you overview of Altera also, because few of the companies are working on Altera FPGAs as well. Once you understood the architecture of FPGA internals, then we'll be going into the design, how to design using a tool. So like if you go for Xilinx based FPGA, usually we use a tool called Vivado. Whereas if you go for Intel based FPGA, that is Altera FPGA, so there we'll be using a tool called Quartus. Okay. So but even though it's like two vendors with the same technologies, right? So technology wise it's same, both are FPGA. So tool flow will remain same. So even though the tools are different, flow will remain same. So I'll mostly focus on Vivado based tool flow, where I will teach how to design FPGA based designs using like Vivado based tool flow. And again, similarly, I'll touch upon like how it will differ in Quartus. So that kind of overview or comparison will be usually doing there. So that is about design tool flow, like design flow of our design. So we'll be learning how and how to end-to-end design FPGA based systems. So that we will be learning in the second part of our course. It may be like 2 to 3 hours we'll be focusing on this design tool flow. Once we understood like design tool flow, then we will be jumping into the details. So anyway, synthesis and physical implementation is part of our FPGA design flow, right? So we might have seen that we will be synthesizing, we'll be implementing, we'll be routing in the part 2 of our sessions. But we'll be in detail, we'll be studying like what exactly happening in that synthesis. So how whatever the RTL code you have written, maybe Verilog, system Verilog, or VSDL code you have written, how it is going to map, or physically going to create some kind of circuitry inside FPGA. So that kind of detailed discussion we will be doing in the synthesis and physical implementation part. So this is actually, I mean, like studying what FPGAs will be very interesting, because you might have seen like wherein ASIC, like there will be like different tool flows, and like for the implementation you need to go for a different tool and everything. Like there are different tool sets, right? And sometimes one thing in the ASIC is like you may not get to know, or you may not feel hands-on how whatever the design you have done, how it is going to work actually in the end product, right? But here, whatever the RTL or VSDL code you have written, you can program into the FPGA and check how it is working, right? So that is like, that's why I feel very interesting in this field. So whatever the 5G architecture we design, we actually run on the system, and we can check like how actually 5G is behaving in the system. So such kind of interesting facts we learn in FPGA actually. So so here actually like we'll be studying like design, synthesis and physical implementation. In that majorly we'll be focusing on clocking mechanism and FPGA resources. So in the FPGA itself, there are various hardcore resources, like we have multipliers, we have high-end PCI Express cores, and we have USB cores inside FPGA. We have like ARM core inside FPGA. There are various hard-end IPs are there. So that we will be studying how to utilize that and how to map your RTL code into those hardcore IPs. So such uh, generalized discussion we'll be doing in that part. Okay. Then we'll be jumping into the next part, where we will be majorly focusing on simulation and verification. So see, whatever the RTL code you have written, so usually before going for the board, we it's like general rule, thumb rule we can say, right? So before going to the board, it's better to simulate, like simulate and test how it is behaving, because actually checking the functionality or debugging in the board, it's slightly different, difficult, right? Because we'll not get to know what's happening inside that. Each and every signal you cannot analyze inside like FPGA IC, right? So we have simulation techniques and verification techniques for FPGA, and we have various tools as well. Okay, so we'll be studying those tools, and like we'll be simulating various designs, and we'll be checking each and every part of that. Okay, so we will take some of the example designs of FPGA, and we will check like how to verify that, how to validate that. And if you had studied like UVM or whatever the verification methods, same thing will be applicable here also. Like same thing you can use it for FPGA as well. Okay, that I'll just show you like how we can apply those techniques here as well. Once we study the verification and simulation part, then we will go for optimization and floor planning, timing closure techniques. So we previously we had like in one of the session what I've shown there, I have shown you that like we can go for implementation and synthesis, right? So it is like it will try to generate some gate level netlist. So once that gate level netlist is generated, next in the ASIC, what you do? Usually you do some kind of floor planning and physical design that PD guys will be taking care, right? But whereas in FPGA, it's not actually like physical design, because we are not going for the transistor level. Here we are going till gate levels only. So whatever the designs we have made using like RTL, that we have to map into the FPGA, right? So here also we have to map with the given resource. That is actually very challenging. So in ASIC, you can decide, like for instance, if you're like more resources are there, your area will increase, and still you have option to increase that area, right? Because like a physical designer can take care of that, and in that slightly increased area you can fit that design. But here is not that, it's not in that way. It's like already they have given you one area, and already they have given you some resources. In that you have to fit the design. Okay, so you have to fit the RTL code. That is very challenging. So if you have a very large design, so straight away it may not fit the design. I mean, your design may not fit into the FPGA. So next interesting part is you have to optimize that design. So here your actual digital design skills will come. So here we'll be discussing how we can optimize that design, and also we'll be mostly focusing on timing closure part. Timing closure, it's like kind of CDC. Can someone say what is CDC? What do you mean by clock domain crossing? Abhijit, Monisha, can someone say what is clock domain crossing? Priyanka. So usually your designs will not have like same clocks, right? You might have multiple clocks in a design, right? For instance, like if you're passing a data from high clock to low clock, low frequency clock, or from low frequency clock to high frequency clock, then general problem what we encounter is called like metastability issues, right? We may miss the data. So we should have suitable circuitry inside FPGA to handle those clock domain crossing. So that is also like clock domain crossing and timing closure, all these things, right? That is also very important interview aspects. So there where you will be like frequently you will be facing interview questions. So that concepts we'll be discussing in detail how we can handle or tackle those clock domain crossing issues. Okay, and even like STAs, static timing analysis, how to solve setup time violation, how to solve hold time violation. And in the floor planning, we have various techniques called T block and other stuff. So that also we'll be studying in detail. Then once we have like a bit file is generated, so you have done floor planning, you have done synthesis, you have done implementation, you have like bit file generated. Next challenging is like next challenging task is basically how to test it on board. You have hardware, so you have to program that hardware, whatever the existing hardware, and you have to test it on the board. So for that testing, we have various mechanisms. Like we have tools like integrated logic analyzer. You can see what is happening, like how you see in the simulation, right? In a similar way, you can see some waveforms, like what is happening inside your FPGA. That we have something like JTAG scan chain based methodology. So that we will be studying in detail. So VIO and ILA based techniques. So this is maybe like mostly the technical part discussions, which like as a short-term course we may be covering. So it will cover from RTL design to till the testing in the board. So that flow will be testing in detail each and every concepts like synthesis and timing closure, those things. Once we study all these stuffs, then like I try to, as I'm being an industry in like maybe like several years, so I try to cover few of the topics like what usually we do in industry in the FPGA field. So I'll show you some of the projects what we do in FPGA, and I try to review those projects. Okay, as like how whatever the concepts we have studied till here, how we can apply to the real-time projects or like real-time specification we get from the customers. Then I'll focus on like frequently asked interview questions, so that I'm being a recruiter, how I ask to the students or like candidate. So we will focus on those frequently asked question in FPGA domain, and like how we can add resume pointers. So how it will be like, I mean, you can see, you can get so many skill set in FPGA if you search in the net, but mostly like industry will not be expecting those resume skill sets. So you might have seen like most of the people will be writing UART and I2C using FPGA. That skill set will have most of the people, but what makes you unique in FPGA domain? So that pointers we will discuss, so that like it will be helpful for you like applying in your future careers. So then I try to conduct a mock interview to each of the students, like maybe 20 minutes of mock interview. It will be something like I'll be conducting to one student, and like others will be audience. So you need not mind, like since we are all learning in this, like we are all in learning environment, so you don't mind even if you give wrong answers, because like everybody is like in the learning mode. So we'll be having like it's like optional. Again, it's like optional, it's your choice. If you don't want to attend that mock interview, it's fine, but you can see, look into like others mock interview, how it's happening. So that's what overview course plan what we have planned for this particular FPGA crash course of like maybe 18 to 20 hours. So any questions on this?
Sir, you will means that tool you will use, that is Questa Sim.
No, see, Questa Sim is only for simulation purpose, right? So
Yeah,
that
yeah.
is a
For simulation process only, I'm asking because that's why I asked you. Means that you will teach us on Questa Sim only, no?
for simulation. I'll teach you on Questa Sim, as well as I'll show you how to do it in Vivado itself. Vivado also has that simulation environment. So
Xilinx. Yeah, yeah,
Xilinx Vivado, yeah,
yeah, yes. Thank you, sir.
yeah. Any other questions like Monisha and Abhijit?
Sir, I have a doubt. Like FPGA engineer will do all the things which we are, where there are separate engineers for SIG design, no, sir. Like I'm asking, like floor planning, there will be a separate engineer. Synthesis, there will be a
Yeah,
separate.
see, actually, why we are doing actually like FPGA engineer itself is doing all this stuff is because most of the things here like you need not do manually. For instance, floor planning, whereas in ASIC you have to do manually because like in the given area you have to fit it like each transistor level you have to plan it, right? Here everything is already floor planned, right? So that resources are available, LUTs are available, pins are available. You need not manually do it. So tools will take care. Most of the things tools will take care. Sometimes what will happen, it will not meet the timing, so that time you have to manually interfere like why it is not meeting the timing. So uh, that's why like you may not be like intensively like how actual physical designer engineer is doing that kind of floor planning, you will not be doing here. That's why most of the things FPGA designers will take care here. Everything will be taken care by one engineer here usually. In FPGA, you will not have something like FPGA floor planning engineer, FPGA STA engineer. You will not have like that. So in general, we say FPGA system design engineers, right? So sometimes in like nowadays, you might have heard something like Zinc SoC, right? So even ARM processors will come inside FPGA. So uh, for that ARM processor coding, sometimes like in some companies, separate software engineers will be there. So we have to interact with them and for interfacing this FPGA design with like ARM core and stuff like that. But how in the ASIC, right? Usually that different engineers will not come here. Like FPGA verification engineers are there. Separately, verification engineers are there, where they will be doing how your ASIC verification flows are there, right? Similar way they'll be doing FPGA verification as well. But I mean, functional level verification still like FPGA design engineer will only do because you have to identify that issues, right? Functional issues. But
Sir, average life cycle of an FPGA project, sir. Like in
it depends. It depends actually. Like in ASIC, it may go very long period, right? Because it has to go till fabrication. But in usually, if you come to like 5G projects, like what we are working, average life cycle is like within 3-4 months we finish it off one project. Because you need not it need not go for fabrication. Only thing which takes time is like that FPGA has to fabricated in the PCB. So PCB will take some time. Other than that, whatever the development you have done, and especially whatever you are doing, right? So in case of ASIC, whatever you do, whatever the functionality you do in simulation, you might have seen it is working fine. But actually in the real time, like actually in the physically, if you want to see how it is working, that fabrication has to complete, right? But whereas here immediately you can like dump your code RTL into your FPGA and check how it is behaving. That is one good thing here. So if it is not working fine, immediately you can change your architecture and rebuild. So here like we'll be more exposed to like entire design flow, right? So you can see actually you can see how if timing is not meeting, you can see it in FPGA like how it is not meeting and it's how it is not working. So all these things you can see in real time. So and one good thing is like anytime if you don't like FPGA and you are fed up with like working with FPGA for a long time, you can check just jump you can jump into ASIC engineer. But being an ASIC engineer coming into FPGA, it's very difficult because usually he'll be like not knowing how to deal with like hardware and how to program, and those tools flows he'll be not knowing. He'll be like, if you go to ASIC field, right, you'll be working on one field. You might have not, for instance, if you worked on front end, you will not work on this one, right? So maybe you might have not worked in STA, static timing analysis, or you might have not worked in like floor planning stuff like that. So that problem will not come here. So we can easily jump into ASIC, but being an ASIC engineer, it's very difficult to jump into FPGA because I mean, being a recruiter, I don't prefer like ASIC engineer for FPGA field because I mean, they have their own expertise in ASIC, they can continue there, but FPGA, it's like all of the different. But usually in companies like Qualcomm or like Cadence, they do consider us for ASIC because we'll be having entire that flow will not differ much. So we'll be having knowledge of entire flow from floor planning to timing analysis, everything.
Hello.
Yeah, tell me.
You will do any industry level project during this crash course? Or will you teach normal projects only during the flow?
No, industry level, that's what, like I plan to take a few of the industry level projects, what we are doing in industry. But see, actually, step by step, I cannot teach like how to build and all. I can give a specification wise because like it's a short term course, right? That project, like if I want to, in detail, if I want to explain, it may take more than 10 hours for that itself. Like in the details FPGA courses, what we take, it will be taking more than 10 to 20 hours on project itself. But maybe in 2 to 3 hours, I can show you like how it is being done, and I can give you as an assignment also few parts, and you can try it on your own. So that like what we can do, like if you have any doubts, you can ping me at any time, right? So if you are facing any, like for instance, if it is not synthesizing, if you are facing any timing issues in that, like I'm always open to help you on that because it will be learning for me as well. Like if you make some mistakes, that will be learning always, because in future if I find similar mistake, I can correct that, right? So that I can do, but it will be like I'll be explaining in detail like what industry projects we had.
Yeah. Overview of the project and the main like STA timing analysis we will be discussed, right?
Yes. Few of the important pointers of that project we'll be discussing. Yeah, architectural wise we'll be discussing mostly.
That's thank you.
Yeah. Anything else? Okay. If no questions, like shall I wind up the session?
Sir, at what time tomorrow's session will be, sir?
That I'll just coordinate with Srinivas. So, and based on like I have to coordinate. You can coordinate with Srinivas or Manohar online.
Okay, sir. Thank you.
Thank you, everyone.